Hello, everybody, and welcome to another Agile IT Tech Talk. I'm your host, Sean Spicer, Head of Marketing over here. In my office, I'm joined by Alex, who gave last week's Tech Talk. He'll be our on-hand engineer. But today, I'd like to give a special welcome to our guest, Sean Weisfeld, who is a Microsoft Cloud Solution Architect, who's been working with us very closely on shaping and developing our DevOps offers and services. And today, he's going to be presenting his DevOps Hackathon. How you doing today, Sean?
Very good, Sean. And I think any call is better with more Sean.
We've got two Seans in the company, so we could have had a Sean party today. Can you tell me a little bit about what the hackathon is?
Sure. We've put together this hackathon, and the general idea is to give folks real-world, practical, hands-on experience working with the Azure DevOps tooling.
All right. So I'm going to go ahead and just pass the screen over. We've been a little bit PowerPoint heavy, which we try not to be in the past weeks. So I'm just going to give this straight over to you.
Awesome. So I am going to try to do as little PowerPoint as possible. I've seen your earlier DevOps talk that your team did, and I refer folks that want to find out more about that some of the core bits back to that talk. But I really wanted to drive home a couple of key points. First, and I'll make this deck available to you all. First, I'm going to show some tooling today. As you guys well know, DevOps is more than just about the tooling. And I think that's really where our partners like Agile IT come in for a company like Microsoft, insofar as they can help you with the people in the process work that goes alongside the tooling that we can provide. Right, they can provide that help along that journey, because it's really about changing the culture to really embrace the process, and not just buying a tool from a vendor, whether it's our tool or an open source tool or whatever. It's more than that, and I think that's really where folks like Agile IT can help you all. So I got a lot of stuff in this deck. I think you guys have seen most of this. And I'm going to skip past it and leave most of it for an exercise for the reader or to go watch that other presentation. But I do want to drive home a couple of key points. One, as you guys know, if you've seen that other presentation, there's 5 key pieces of software inside of Azure DevOps. Azure Boards, which does all your work item tracking. So you know what to do and who's doing what work. Once they've done that work, they build that code into Azure repos, which provide both Git and distributed Git and Team Foundation Server version control. Once you have the code there, I now have Azure pipelines to build, test, and deploy that code in a repeatable manner. I have Azure test plans to help me with the testing to make sure that my code is right and that it's doing what it's supposed to be doing. And finally, Azure artifacts. A lot of times you want to build a NuGet package, a Maven package, an NPM package, and you need a place to host those types of artifacts, and Azure Artifacts is the place for that. What's notably missing from this picture is some of the other features that are inside of Azure, namely things like our monitoring suite with Azure Monitoring, including Application Insights and Log Analytics, and our other Azure services like ARM templates for infrastructure as code, like Azure Key Vault for secure secret storing and things of that nature. Again, the slides have a lot more detail. I do want to mention this open source journey that Microsoft has been going on for the last 5 or so years. Open source is something that we're really embracing. We're a top contributor to open source projects on GitHub. We spent a couple of $1 billion to support the open source community by purchasing GitHub. We're a contributor to the Linux Foundation and things of that nature, a major contributor to the Kubernetes Foundation. So a lot of those things really, we're really embracing open source, as well as taking our stuff, things like .NET Framework, and open sourcing those tools. And I'm going to show you a pipeline today that uses all of our tooling, but there's nothing to say that you can't mix and match tooling that you already have. So if you have container, if you have something like Octopus Deploy, you really love Octopus Deploy, you have a huge investment in Octopus Deploy, by all means, I'm not telling you you need to throw all that away and start over with Azure Pipelines. We can integrate with Octopus Deploy and things of that nature, Jenkins, you name it. So I'm going to go directly to the demo because I promised you guys a long demo and I've been blabbering on for 5 whole minutes. So let's go to the demo. And I have this beautiful website. It is obviously the most simplest website. It is actually a .NET Core application running in a container on our Azure App Service hosting environment on Linux. So it's our Linux container running out there on Azure. I just chose this because my background's as a .NET developer, so this was the easiest thing for me to put together for you guys. And App Services makes it super easy for us to deploy these things real quick. But we can see I have a little website here. It's not very exciting, but if I go to the About page, it's got a problem, right? And the last thing you want to do is be beholden to your users taking screenshots and to notify you about problems, right? You want to know about those problems when they happen. So if I go into Azure itself, I have Application Insights set up, and it's configured with a dashboard. This dashboard gives me a heads up display about what's going on inside of my project. In this case, who's using my project, the information about reliability, errors that the project has generated, and things of that nature. So I can go ahead and drill into any one of these things and get more details. So I'm going to drill into reliability. I see a spike in errors. I want to see what's going on. I can see that I have a couple of spikes over here. I can see the actual web pages that were generating the errors. In this case, the home about page is the one that I want to look at. We can see, well, what kinds of exceptions was I getting on that page? Well, there were 500 internal server errors, and they were throwing not implemented exceptions. I can then drill even into the detail about one of those exceptions. Now, all of these features are part of Application Insights, and Application Insights will work even if you're using nothing else. The application doesn't even have to be running on Azure. It can be running anywhere, and Application Insights will still work. It just logs all the data to Azure. So you can see my application is simple. I don't have any dependencies, but if I had dependencies like I was calling a SQL server or a HTTP call in from my website, I would see all of those dependencies in this nice little waterfall chart. So I can see where the website's spending time, what's going on. I can also pull up a lot of details about what happened. Right, this is all the information that my developers will need to actually go fix this problem. So what do I do? Right. Well, if I'm old school, I pick up the phone, I start calling people. I might take a screenshot of something and try to send it to somebody. But what I can do right here from within Application Insights, since I have it linked to Azure DevOps, I can actually go create a work item directly from here. So it took all of that information that we just saw, and it's going to dump that right into the work item so that the person that's triaging new bugs for my application can see that information right away. So I'm going to go ahead and flip over to Azure DevOps. Here's my Azure DevOps, and here is my board. And if I refresh my board, we can see that there's a new bug on my board. There's a bug on my board. We can see that bug. If I open up that bug, has a whole bunch of information about what's going on. Namely, all of that stuff that we just saw in Application Insights is right here. Right? The person that needs to go fix this bug knows exactly what URL happened, exactly what the response code was. They even have all the information they need to go look up this exact request in Application Insights if they need more detail. So now I have tracing from the actual problem that happened to the request to go fix that problem. Now this is a bug, but the same concept, the same traceability, it would work if it was a feature request or something of that nature.
And
So I'm going to start. Oh, I'm
being
sorry.
just a little bit old school, I have to say this is a really nice bug report. And having had to hand write bug reports and collect this information, this is impressive. When we did our demo, we didn't think to have any errors thrown. This is cool.
Well, I know all my code throws a lot of errors, so I know how important it is to get the details of those. Or you even see that in Austin, Texas when I did it. So I'm going to start working on this error, right? So my project manager, he's going to, or he or she is going to assign somebody to go work this error. I'm the only one in the system. It's a little test system. So my name's there, and then they're going to move it to, okay, the active state, and that's going to move the card to the next swim lane. Now I could have just dragged and dropped the card to the other swim lane, but I chose to do it in the state there. So now I, the developer, has now been assigned this work to go do. Let's go fix the problem, right? So let's go look at some code, right? Well, I had the whole bug report. I know exactly where that bug was, and I'm going to go fix the code. Now I'm going to fix the code by just editing it right here in the browser. But obviously, any developer tool, whether it's Visual Studio Code, something from JetBrains, you name the tool, it all works here. At the end of the day, it's just a Git repository, so anything that knows Git can check stuff in. So I am going to, if you're .NET developer, you know that, hey, that's the thing that was throwing the exception. I'm going to do what all good developers do when they find bad code, just comment it out. And then I'm going to go commit that change. You can see I have a commit message in here. It asks me what branch I want to commit to. And then I can also link it to a work item. So in this case, I'm going to click this drop down to link it to a work item, namely the one that we just created. But let's say I wasn't using this UI, and I was doing this from the Git console, from the Git command line, right? I could just type in here the bug number. I think it was 74. Yeah, it's 74. I can just type the bug number in my Git commit message at the command line or whatever, and it will automatically link those things up. So I have traceability from problem happening to request to fix problem, now to the actual code that fixes the problem.
Oh, that's
so
great.
If I go ahead and commit that, you can see that it yells at me and says, hey, wait a second, you're not allowed to commit to the master branch. Well, just like any good DevOps organization, maybe I'm using something like Gitflow or something of that nature, my master branch is protected, right? A developer working on a feature or a developer working to fix a bug has to fix that bug in their own branch. So I'm going to just go in here, create a new branch. We're going to call it Sean Fixing Things. That's a beautiful branch name. And I'm going to go ahead and commit that change. So now I have the change committed, and if I look at my branches, we can see that I have two, the master branch and Sean Fixing the Things branch. So now it's time to, I think I fixed the problem. It's time to execute a pull request to push this change, to pull this change into the master branch. So I'm going to create a new pull request. I'm going to go from Sean Fixing the Things into the master branch. You can see that my linkage that I did from the work item to the check-in is held over onto the pull request. So now I know that for this pull request, it was to address that work item. And I also can see here quickly at a glance what code changes were made. So I'm going to go ahead and create that pull request. And that pull request is going to start the traditional pull request flow. That traditional flow includes a number of things. The first being, well, I want to probably ask my peers, what does this look like? I also want to maybe require, as a company, some policies on this pull request. So you can see I have 3 policies set on my pull request. One is that, hey, every pull request must be linked to a work item. 2, every pull request requires somebody to sign off on it, that they approve it. And 3, the pull request must execute a build. So since this is a small little test system, I'm going to approve my own pull request, which obviously isn't what we're going to do in production. I'm also going to set this guy to auto-complete. So that means when that build finishes, it will automatically merge this branch back into the master branch. That way we don't have to go back in and click this button later. Let's go look at that build that's happening right now. So I have 2 builds. This one build that I call CI pull request, so continuous integration pull request build. This build is running, and as the build runs, we can see details about the build. So you can see that I can see the spew from the console of the virtual machine where this build is happening. If I go pull over into the builds again, and I go edit the build pipeline, we can see what this build does. So this build runs through 4 steps. One, it's going to go pull in my NuGet packages. It's a .NET Core app. It's going to tell .NET, go ahead and build the core app. 3, it's going to run all of my unit tests to make sure all my unit tests pass. If my unit tests don't pass, pull request does not get approved. The last thing it's going to do is run white source bolt. I think this is a really good example of the integrations you can have with third-party tools inside of Azure DevOps. So white source bolt is a third-party tool where there's a free tier. And what it does is it scans your project for out-of-date dependencies. So if I go look at the white source bolt report from a previously run job, we can see when it loads that I have some vulnerabilities insofar as I'm using an out-of-date version of jQuery in my project, and it's suggesting that I upgrade to jQuery version 3.0.0 to fix a cross-domain AJAX request issue in that old version of jQuery. So cool. Once all this passes, right? Once my CI build, my pull request build passes, which I think it's still going. Yep, it's running the white source bolt right now. Once that all passes, the pull request will get completed, in my case, automatically because I triggered it to do so. A check-in will happen to the master branch. And once that check-in happens, I've configured this other CI build to go now and build my master branch and get it ready for publishing my container to Azure Container Registry, where I'm going to store my container. So let's go take a look at that build process. If I click on edit, we can see that build process here. We can see that it has a trigger that says, hey, enable continuous integration anytime anything's changed on the master branch. And it has a couple of tasks in the process: restore, build, and test. We saw that before. Publish, which will actually go through and take my .NET Core app and stick it out on a folder on my build machine. And then finally, this Docker step, which will take that stuff that .NET put in that folder and actually publish it into a Docker container using the Docker file that's in my source control system. It'll take that Docker container and shove it up into Azure Container Registry. Obviously, it works with other container registries like Docker Hub or whatnot. So if I go to my resource groups, we can see where that container is. And here's my demo. And that container lives over here. Now, this is just what I chose and how I chose to deploy my project to build everything into a container. But there's other ways of doing it. There's a million ways to do it. This is just an example. And so you can see here, every time I build my project, it gets me a container, and that container is tagged with the build number. So each one of these is a different container. So each one's tagged with a different build number for that project. So that's the output of my build step, code that's ready to be deployed. So the next step is to actually go deploy that code. So if I go over to my release pipelines, you can see I have 2 release pipelines. The first one I called infrastructure release. What this guy does is actually runs an Azure Resource Manager template. It actually runs it 3 times to deploy all 3 of my environments. And I'm doing this because now I can take, since Azure supports infrastructure as code, I can take, instead of having to like click on things in the portal, I can take all of the look and feel of what my my deployment looks like, put it in an ARM template, store that ARM template in Azure repos, version control it, and now I can also version control my deployments. So if I go back to the releases, we can see that for the infrastructure release, the 6th release of my infrastructure that includes the code at this check-in point, right, is what's deployed out to all 3 of my environments. Right, so it includes that set of infrastructure. That's the last set of infrastructure I deployed. So now I have a good traceability. You can see also that in this case, release 4 and release 5, I chose not to deploy either one of those to test or production. Right, those never made it. There was something wrong with them. They never made it to test or production. So I can see from these green check marks which infrastructure was deployed to which environments and which one wasn't, and which one is the current one with the green dark coloring in. So that's my infrastructure release. Now I have this set to release manually because I don't want to have to redeploy my infrastructure every time. but my application itself, I have that guy set to release in an automated fashion. So my build is still happening, so we don't see the current one happening, but we'll get an idea. We'll go look at the release. We can see that the release waits for the build to finish. Once the build finishes, it will automatically deploy. In my case, I wanted to automatically deploy to the dev environment. And then I have it deploying to my test environment and then to my production environment. But I don't want it to automatically just drop it out onto my test environment. I need to have my test manager approve it. So you can see here I've added, in this case, a human step, right? It requires an approval of somebody on this list, in this case me, to approve this before it can go out to the next step. And all of this is audited, so you know who approved what for which environment. I can also define some deployment gates. So if I need automated steps to run, maybe I'm going to run some automated testing code or something like that. I can do those. I can do that as well. Let's take a look at each one of these guys, because they're all pretty much the same. They're basically saying, hey, go get that container with the right build number and deploy it out to this Azure App Service. In this case, the one that ends in -dev. Okay, let's see if our deployment has caught up with me. So it looks like the build has finished and the release is now starting. We can see that release 4 just started off. We can see that currently it is going to deploy it. Oh, it's queued for deployment out into dev. It started deploying out into dev. So now we can see it actually going through the process to deploy it out to dev, right? I get full insight into what's going on. I don't have to actually go here and watch it every time, unless you're like me and like watching spew from consoles, because it does look kind of cool. So that deployment will happen. Once that deployment is finished, obviously our bug is going to be, hopefully our bug is going to be fixed, right? Hopefully we've done the right amount of testing. But let's flip back over to our Azure boards. And if we look at our bug now, we can see that it's sitting in the resolved column. Wait a second, we left it in the active column. How did it get to the resolved column? Well, it got to the resolved column because we closed the pull request. It knew that, hey, I closed the pull request. That means you fixed the bug. We're going to move it over to the resolved column. Now, once it's finished its deployment, it's out in production, I can go ahead and close the bug by just simply dragging it into the closed column. So we've gone full circle. We've identified a problem in production using application insights. We've opened a work item ticket to tell our developers, hey, we have this problem. Here's all the information about it. Go fix it. We've assigned a developer to go fix that problem. We've executed a code change to go fix that problem. We've associated all of these things together. We've issued a build to build our code into, in this case, a container, and then a release to go take that container and bring it through the release pipeline. And if we look, let's see, oh, see, we're done with deploying it to dev. So if we go to the dev instance now, dev, home about, our dev instance should work as soon as he finishes waking up. And yay, our dev instance works. If we go back over to test, our test instance should be still broken. And then we can go ahead and deploy. So our test instance is still broken, right? I can now go ahead and just approve it, right? I click on this guy. Now I have my email closed. Obviously you guys don't want to read my email, but I've also received an email that says, hey, this thing's waiting for you. Do you want to approve it? Right? Do I want to approve it now? Or do I want to approve it to go out after business hours because currently my testers are using the system? I'm going to approve it to go out now. And just with that, it will kick off the process to actually start the deployment out to my test system. So I know I went through that whirlwind. My goal was to get through it in 20 minutes. Hopefully I did that. I think I did that. I think I'm 5 minutes over, but hey,
You kept up.
cut me
That
some
was
slack
great.
on that one. So I want to drive home a couple of things before I turn the floor over for questions. One, we call this Azure DevOps. I don't know what the thinking was behind the naming, but the way I think about it personally is it's called Azure DevOps because the SaaS service that I just showed you runs in Azure. I can also run Azure DevOps in something we call Azure DevOps Server, which runs on premises or frankly any place you can run a VM. Now, Azure DevOps is definitely not just for deploying solutions to Azure. I showed you deploying solutions to Azure. I love deploying solutions to Azure. I think Azure is a great place, if not the best place to run your solutions. But it doesn't mean that that's the only game in town. And Azure DevOps supports deploying to any major cloud platform, or frankly anywhere, because you can deploy with things like FTP or web deploy. But it'll deploy to AWS, it'll deploy to GCP. Azure DevOps supports, you saw builds that were happening on Ubuntu machines today. I can have builds that are happening obviously on Windows machines. I can also have builds that are happening on things like Mac OS. And I can deploy things like containers. You saw that today. I can deploy to Kubernetes. I can deploy to just raw VMs. I can also integrate with other tools. So if you love Azure repos and you already have an investment in Jenkins, I am not going to tell you, Microsoft is not going to tell you to throw out all that stuff and start over. Go ahead, continue to use your Jenkins if you love it, and use the Azure DevOps tools where it makes sense. You can kind of mix and match. It's kind of like the Chinese food menu, right? And it's not something that just like Sean's here telling me that Microsoft telling me to go use these tools, but Microsoft uses something else that's special. No, we use these tools. If we look, I think I still have it open. I do. This, we looked at release pipelines. You can see, obviously, I don't have permissions to edit this one because this is the production release pipeline to deploy Azure DevOps, written in Azure DevOps. It's like
Wow.
cats and dogs eating each other and stuff like that. If I zoom out a little bit, you can kind of get the scope of this. So each one of these deployments is another region in which Azure DevOps is being deployed. And as they go through the deployment process, they increase their blast radius. So first they deploy to West Central US, right? Very close to Seattle. If there's a problem, they can fix it real quick, right? And then it grows as they start deploying to more and more regions across the planet.
Wow.
So obviously your build pipeline your release pipeline might not be this complicated, but it works for projects of all size, small, large, what have you. And I really like the content that's up on this aka.ms/devops at Microsoft, because of it talks about the journey that we went through. And I think that's super helpful to kind of see the pains that we've had. And that way you guys don't have to learn from don't have to have those same pains. The last thing I want to touch on real quick is what does this stuff cost? So if you're building an open source project, you can use Azure Pipelines and Azure Boards and Azure repos for free. If you're a small team under 5 people, you can use all of this stuff for free. If you're on a larger team, you can either purchase it by the seat, but also if you're a Microsoft shop and you're having Visual Studio, if you have a Visual Studio subscription, you get this as part of your Visual Studio subscription. So you don't have to buy anything separate. It's already baked into your Visual Studio subscription. Now, I know you guys we started off talking about why this workshop thing. Well, that demo that I showed you is actually what we build in 12 hours, hands-on during the workshop. So I think that's super cool that you can go from empty project to all of that stuff I just showed you in 12 hours, and as a novice just getting started to this.
Yeah, and we were talking about that prior to the start of the session. And I do like that it's flexible, that 12 hours can be 2 6-hour days, a couple of afternoons throughout a week. Because when you first said 12 hours, my first thought was starting at 6 in the morning, getting done at 6 at night, and how bad my head would hurt. But no, that was really cool. And so at the end of the hackathon, you've pretty much built what we've just seen, right?
Exactly. You get that. You have that exact environment. You get to build it yourself, and it's not like a traditional lab type thing where during the hackathon we're telling you click here, click there, click that, click this other thing. We do it in what we call a challenge format. So we give you some tasks to complete, and then you work with your squad, a group of like 5 people, to go complete those tasks. Every person gets their sets up their own environment to go build out that thing that I just demoed. But you get to work it as a team. So if you get stuck on something, somebody else on your squad can help you out, and you guys can learn from each other, which I think is one of the most valuable things of these types of things. If just giving you instructions on things to click on, it become an exercise in following directions as opposed to a learning opportunity. And frankly, that hackathon is something that we wrote internally at Microsoft to help train our teams on this tooling. So it's something that we deliver internally, and it's something that we work with our partners like Agile IT to deliver out to you guys as a community.
Yeah, so everybody on the line, everybody watching on YouTube, you can go ahead and click the link down below, and we will have a link to find out more about these hackathons, which we will be delivering in the future. Earlier, you were talking about the squads, and one thing I really liked is you were talking about the low barrier in terms of prerequisites, so that you would have maybe a infrastructure engineer working with a developer. And one of those key things about DevOps is breaking down those silos. Who's the who's the hackathon really intended for?
So I would argue that the hackathon is intended for anybody that would be working through this process. I think it would be great that the folks that attended are not only developers, not only operations teams, but even things like even folks like project managers. I think it does a really good job of walking through the whole process, and we've taken the parts of it that are technically confusing and kind of given you those pieces so that we can really focus on that entire workflow that we just saw, and not get bogged down in, well, you're missing a curly brace on this line, or you don't have this tool installed, or stuff like that. We try to make it a really low barrier entry, because we really think that giving folks the opportunity to get hands-on with the tools, and even walk through a small little simple workflow like I just demoed, really gives the team some, I don't know if it's the best word, but some visibility, some sympathy into what goes on the other side of the fence, so that you can start building that we're a DevOps team, as opposed to, well, I'm the project manager and I'm going to throw it over the wall, or I'm the developer and I'm going to throw it over the wall.
I love that distinction. Sean, thank you so much. Alex has finally lifted his jaw off the desk from seeing the DevOps pipelines. That was epic. I just want to say thank you to everybody who's watching online. We're going to go ahead and end the recording here.